All right. It's good to be working with you guys again today. This is Mr. Mays. Today I'm going to show you everything you're going to need to know for the upcoming quiz that's going to be on hypothesis testing. And the questions on the quiz are going to look a lot like the one that I have up here on the screen for you. I'm just going to walk you through the way we do these problems. And as I do that, I'm going to walk you through the different ideas that you need to know notes-wise. So if you need a review on any materials, or if there's something that you feel like you missed or didn't quite grasp from the past few classes, this is the right place to be. It's good to hear from you, to see you. I can do neither of those things, but I'm going to imagine them in my head, and we're going to start working. Okay, so the first thing to be aware of here is a hypothesis test is going to require you to denote or offer two very important things. And those are your null hypothesis and your alternate hypothesis, aka the ho and the ha, as we've talked about in class. So the first two things I'm going to do are I'm just going to write those down because I know those are going to be the two things I'm going to have to write out for this problem to start, okay, before I even do any calculations. Now, if I read, I should be able to set up my null hypothesis and my alternate hypothesis based on the first part of this question. The question says, a company claims that 60% of consumers prefer its new product to the old one. In a survey of 100 consumers, 73 expressed a preference for the new product. Is the company correct in arguing that more than 60% of consumers prefer their new product, or are they liars that sit on a throne of lies? Let's find out today. Okay, so our null hypothesis will always be based off of our null proportion. And in this case, our null proportion is 60% or 0.6, okay? Because that was what they assumed to be the case. This is assumed to be true, that 60% or 0.6 of customers enjoy the new product over the old one. Okay, so in my null hypothesis, I will just write P is equal to 0.6. And then I'm going to write my hypothesis statement. In this case, it's as simple as 60% of consumers prefer the new product. Okay, simple as that. And that should feel pretty wonderful because what we've done essentially is we've taken some data and we've proven something of an argument, right? That's our first hypothesis. So when you go in to write your null hypothesis, oh, whoa, no, I don't want to do that. When you go in to write your null hypothesis, it should read something like that, okay? You should start with this argument of what the proportion is. And then you should follow it up with a statement of what that proportion means in this case, right? That 60% of consumers prefer the product. And this is the null because it's the thing the company assumes to be true at the start. Now, what the company is trying to prove is that actually, in fact, overall, more people prefer the new product than just 60%, okay? So even though, I'm gonna note this down, even though we see 73 out of 100 in our consumer market enjoying the new product, that's not gonna show up in our hypotheses. So our alternate hypothesis is actually going to read that P is greater than 0.6, right? Because everything should refer back to the null hypothesis. So our alternate hypothesis is that more than 60% of consumers prefer the new product, right? So I'm going to write that down. More than 60% of consumers prefer the new product. Okay, so again, we have our statement and we have our proportion, okay? Now, we don't know for sure if we can argue that more than 60% of consumers enjoy the new product because even though we have a sample proportion, the 73 out of 100 consumers, we're not sure if that's strong enough to prove our point. So that's what we're gonna find out today. So just to make it clear, that's what an alternate hypothesis should look like. Do not, I'm going to repeat this one more time, but do not put P hat in for P, okay? These are two different things here. This is the proportion that we're using as the null, aka PO. You could also write it as PO, the null proportion. And over here, this will be P hat. But if you're thinking about the P hat, aka 73 out of 100 in this case, you're on the right track because the next thing we're going to do now that we've got everything lined up and we've written our null and our alternate hypotheses is we're going to set up our variables for our equation. Now the equation you'll need to know is that z is equal, and I will give this to you on the test, z is equal, or the quiz, to p hat minus the null proportion divided by the square root of the null proportion times 1 minus the null proportion divided by n, aka our sample size. Okay, so that will be the equation we follow. Please forgive me if my handwriting is a little ugly. I will try and clean it up as we go, but there we go. Okay, and remember that this square root goes all the way down. I'm always going to have to reiterate that, right? Because it can be, we can forget sometimes, but it will go all the way over that denominator part. Okay, and in fact, I'm going to highlight this in bright red so that we can remember it, because we will be returning to it over and over again. Okay, this is the sort of calculation heavy part of the lesson. But the good news is, as I'm sure all of you can remember, it's pretty easy to plug this stuff in Desmos now, because we don't have to solve for any denominator variable, right? We're actually solving for z. So I'm going to put that at the right under here. I'm going to say z equals question mark, because that's what we're looking for, okay? So we're looking for a z-score. Our p hat will be that 73 over 100, because it said 73 out of the 100 people surveyed preferred the new product. And we write that as a decimal. That'll be 0.73. Beautiful. So we have our p hat. We have our null proportion, p null, which is 0.6, as we know from our hypotheses. Perfect. And the last part is n, our sample size, which we happen to know is 100, because that's how many people were sampled when they did this trial sample. And now we have all the variables set up. So if you will, the next step, now that you got all your variables on the side and you have your equation, you're just going to map that out. So z will equal p hat, which in this case is 0.73, minus the null proportion, 0.6. That's your numerator. The denominator is going to be this big ugly square root, but it's going to be 0.6 times 1 minus 0.6 divided by 100. Now be very careful and very sure that in this place you're not throwing extra zeros where they don't belong, that your decimals are in the right spots. And then you're going to plug this into Desmos, okay? So plug this all into Desmos, and you'll know you've done it right if for your z-score you get about 2.65. It'll keep going on for a long time, but that is what I get, is about 2.65 for my z-score. Again, I would highly recommend double checking that your square root goes over the entire denominator. Double check that there are no extra zeros, so it shouldn't be 0.06 or 6. Remember to put your decimals in the right places, and you should end up with a z-score of about 2.65. Then you'll go to your z-score sheet, and you should be able to look it up, and what you will find is that for a 2.65 z-score, your p-value, the p-value that shows up, should equal about 0.99598, bunch of numbers, okay? And I am okay with you rounding that up to the third decimal, so we can do 0.996. That's totally fine with me. And you should be already very close to celebrating, because at this juncture, you have done most of the hard work, right? Now there are some conditions you need to check on. These are very important conditions, so I'm going to put them in the red to the left here, okay? There are 3 different conditions for our null proportions that you have to think about. Either p null is greater than the proportion that we're looking at. Otherwise, it's less than, or it's not equal to, okay? And what we mean when we say this is, I'm actually going up to the top here where it says for the alternate hypothesis, p null is greater than 0.6. So whatever the original null proportion is, that's what we're guessing on right now. Is the proportion actually greater than itself, right, than we think it will be, right? Because this p null is going to become the new null hypothesis. This is the future, if you will, and this is a p null of the past, right? It knows nothing of the world. Now, if you find, and this is, again, I will write this at the top, this is for your alternate hypothesis. So, if in your alternate hypothesis, and actually because we're comparing it to the new p null, I'm just going to call it the p, the proportion, okay? Now, you're asking yourself, essentially, if we can trust that the proportion is greater, or if we are pushing to find out if the proportion is greater than the null hypothesis, what we're going to do is we're going to do 1 minus the p-value that we find. Okay? And there's a reason for this. Let me map this out for you on a little diagram here. So let's imagine our beautiful normal curve. Da, 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 da. That was a little Jurassic Park reference for you. Okay. We found a z-score, as we've said, right? And I'm going to use the red dash line to show you where the z-score is. So 2.65. If we assume our center is right about here, our center should be our null proportion, which in this case is 0.6. That's the center of our normal curve, because that's where the majority of our values hit. That's what we assume to be the truth. Sometimes it'll go higher, sometimes it'll go lower, but we trust the exact center to be the true null proportion. Now our z-score is a z-score of 2.65. So it is not 1, not 2, but slightly more than 2 standard deviations to the right, because it's positive, of our p-hats. This is our z-score. AKA p-hat, or our p-value, right? I should say, not p-hat. Silly me. Not p-hat. This is the z-score that tells us our proportion, our p-value, right? Now, there's an issue here, because in the first case that I've given you, our proportion is greater than the p-value. That's asking for this data right here. What are the odds that we hit this z-score or go beyond it, okay? Now, you might remember from many units ago, I'll highlight this in green. When we get a z-score, the decimal we initially get, in this case 0.996, represents all this data. And that should make sense, because 0.996 is 99.6% of the data. And 99.6% of the data should sit before 2 standard deviations. It's all that. So if I'm asking, however, for the odds that the proportion are greater than the p-value, I'm looking for this data. So I'm going to do 1 minus the p-value to get just what's more extreme than that value. And I'm hopeful that that will make sense to you. Please come and talk to me if that does not make sense to you. On the other hand, if we find ourselves in this lovely situation where, oh, again, my mix up. In this lovely situation, where the proportion is less than, where we're arguing that the proportion is less than the null proportion that we've been given, 0.6, then we just use, we're very fortunate, we just use the p-value that we get originally, right? Because that will give us everything before our own p-value. And so it will be every odd that the proportion is smaller than the z-score I got. The last example is going to be right here. This idea of does not equal to. And if our proportion does not equal to, right, our null proportion, I want you to imagine it like this. I'm actually going to erase this entire drawing so I can make it a little clearer for you. There's probably a way to make the eraser bigger, but you know, I'm not Mr. Tech Savvy. I teach statistics, not computers, so you should probably just get used to some slope ups here and there, but it's all good, guys, because we're going to make it work. Okay, that's pretty good for the now. So, if you will imagine, like we had before, that lovely normal curve, something like that, okay? And we have our null proportion going straight down the center. What I want you to realize is that in these cases, when we get our z-score, again, let's say it's 2 point, really, and I'll be honest with you, before you saw those proportions and they looked kind of off, it's because I set them up kind of oddly. Your z-score would actually be somewhere like this. That's kind of where it would sit, right? With about what remains sitting right over here. So in the case of the problem that we're doing currently, we want to know what happens if the proportion is more extreme than our z-score. So what we would do is we would do 1 minus 0.996, the p-value we found originally. And what we would find for that is about 0.004. So we'll be using that later, but 0.004, that represents this area here. Now for p does not equal the proportion, we're actually asking for both extremes of the normal curve. We're asking for what's known as a two-tailed test. So I'm going to write that down here. This is the one two-tailed test that we will run. The other two values, these two guys here, these are both one-tail tests. Okay? I'll make that one a little clearer. So those are both one-tailed tests because we're looking for either the left or the right tail. In the case of a two-tailed test, aka p does not equal the proportion that we're looking for. We want everything that is not this center area, okay? Because that's where the null proportion sits. And that's where the odds of the null proportion being true actually sit. All of this area here. So we don't want that. We actually want this and this. We want the lower and the upper extreme. So we want double what we want for p is greater than, right? And so in order to do that, because our lovely normal curve is actually 100% evenly distributed, for this one, we will say 2 times 1 minus the p-value. Okay, and that's what that calculation will be, is we will get this value, 1 minus the p-value, the higher extreme, and then we will multiply it by 2 so that we can get the lower extreme alongside it, okay? And some of the questions I give you on the quiz will expect you to be able to do that. So it's important that you have in your notes these 3 different values for p. Either p is greater than for our alternate hypothesis, in which case we do 1 minus the p-value. P is less than, in which case we just take the v-value because we want the left curve, the left tail. And of course, for p is greater, we want the right tail, the higher extreme. And then for p does not equal, we will multiply the extreme, the higher extreme, by 2 to get both the lower and higher tier to get the two-tailed test. Okay, and as I said a moment ago, we're going to do 1 minus for the problem up here, okay, that I've highlighted. And we're doing that because we want a p-value that's greater than the extreme. Right? So I did that calculation. It gave me 0.004. So that would mean that my p-value, and this is important, you would write on your test, your p-value is equal to 0.004, which is a lovely p-value. There's one last step. You are in the final home stretch. The last step that you must follow is in any problem, I didn't write it in this problem, but for any problem, I will give you a significance level. Also known as an alpha, this sort of fish A, okay? And normally that significance level will equal 0.05, aka 5%. And what that means is that if my p-value, and this is important, if my p-value is less than or equal to 0.05, so if it's 0.05 or smaller, 0.03, 0.01, 0.001, then we reject the null hypothesis. Let me put that C in there. Write that more beautifully. If it is less than or equal to the 0.05, we will reject the null hypothesis. Okay? Therefore, we have shown the alternate hypothesis to be viable. Okay? So that's option 1. Option 2 is that the p-value, of course, is just greater than 0.05, 0.06, 0.1. Okay? In that case, you must accept the null hypothesis and reject the alternate hypothesis. Okay? And that's what a significance level does, is it tells us, hey, how significant are these results? If you are at least this significant, it's like a bouncer for the club of rejecting the null hypothesis. If you don't have a small enough alpha, right, or if your p-value is not small enough to meet the alpha or go lower than it, you can't sneak into the club known as rejecting the null hypothesis. But on the other hand, if you have if you do have a small enough alpha, you'll be allowed to reject the null hypothesis. Basically, the p-value will represent, in this case, the likelihood that the null can be trusted. And if it's 5% or lower, we can't trust the null. So in our case, I'm going to do a comparison. I look at our p-value, and it seems very clear that 0.004 is smaller than 0.05. Okay? Therefore, I reject the null hypothesis because I have a small enough p-value. And that should make sense because if we take a look, I did 100 consumer survey, 73% expressed a preference. It seems pretty sensible that if 73% of people preferred the product and we compare that to the initial projections, that we probably could expect that a larger than 60% margin would prefer the new product. Okay, that's how you solve these problems. Those are all the notes you really need to be sure of for this upcoming test. So, as a quick review, you're going to need to know the null hypothesis and the alternate hypothesis. You're going to need to know how to check for each of these, writing them as a proportion. The proportion will be greater than, or the proportion will be equal to. In the case of my question, the last sentence says, is the company correct in arguing that 60% of consumers prefer their new product, or are they liars? We said more than. That's how I know I use this greater than symbol. I will make it clear to you when you need to use does not equal, and when you need to use less than, and then when you need to use more than. We've then, of course, written out our two hypotheses. Beautiful. Sorry for the chaos in my writing. We then mapped out all our variables and looked at our equation, which we then plugged the variables into to solve for a z-score. Once we solved for that z-score, we then took a look at our lovely conditions for the alternate hypothesis. We decided on the one that was the one that would be useful for us. Then we did our comparison, as you can see right over here. And we realized that upon finding the p-value for our z-score, which can be found on the z-score table, you just go down, follow through to the second decimal, and you'll find your p-value. We discovered we needed to do 1 minus that value because it was a p is greater than scenario. That then gave us our answer, which was 0.004, because the p-value we initially found was 0.996. Then we did a comparison with that. We looked at that value, and we looked at our significance level, and we said, hey, it is smaller than our significance level. And therefore, we had our answer, which was that we can reject the null hypothesis. You have been brilliant. Live the dream. I'm proud of you. If you have any further questions, shoot me an email, but I hope this is